Hello and welcome to Mr. Boder's video on naming binary compounds. Make sure you have this worksheet in front of you. We're going to be taking a look at the directions and then working through a couple sample problems before I let you run free on your own to learn the rules of naming some binary compounds or chemical compounds that we will see in the lab. So let's follow along here on the background information. While chemical nomenclature is actually more complicated than this, the simplification covers most of what you need to know in this class. The oxidation state of an element and a few simple rules will help you write formulas for chemical compounds. In writing formulas, the sum of the oxidation numbers for all the elements must equal 0. So let's see how this works. The first thing you're going to need to do is you're going to write the name of the positive element. So in our example down here, you can see that sodium is the positive ion because sodium gives up one electron to become +1 positive ion. So you're going to write sodium. Then you're going to write the name of the negative element but with an IDE ending. So the negative element in this example is chlorine, but instead of writing sodium chlorine, we're going to write sodium chloride to tell us that that is a sodium atom with a positive ion charge to it linked up with a chlorine atom that has the negative ion charge, and we said chloride to indicate that it's negative. If we go back to our background though, we notice that the sum of the oxidation numbers must equal to 0. So in this second example, we have calcium, which is a +2 ion, combining with iodine, which is a -1 ion. That presents a little bit of an issue, because for these to really combine into a compound, we want to end up being neutral overall or canceling each other out. So we're going to need to have one calcium, 2+, and it's going to combine with 2 iodine atoms. I'm drawing them kind of off to the side here. Once it does that, each of these iodines is worth -1. It's going to cancel out the +2, and overall this whole molecule here is going to end up being neutral. We're going to say or name that compound just the same as we did the first compound. We're going to first write the name of the positive element. Calcium was positive, so there's our calcium. And then we're going to write the name of the negative element, but we're going to give it that "ide" ending, so calcium iodide instead of calcium iodine. This is pretty simple to start out with and straightforward. All you need to do is name the positive ion first, and then name the negative ion in the chemical compound, just changing the ending to IDE. Now we're going to add a level of complexity here. So far we've been talking about binary compounds. Binary, that word bi, like bicycle, means two. And so these are sort of like two-sided compounds. They're compounds that have two different parts to them. Sodium chloride is nice and simple because you have one sodium atom combining with one chlorine atom. But we have these things called polyatomic ions. Poly, it comes from a Greek word that means many. So a polyatomic ion is going to have multiple atoms in one ion, and they're going to kind of move around as a group. An example here is a compound with nitrate. Nitrate, NO3, over here on the side, NO3, is one atom of nitrogen combined with 3 atoms of oxygen. And overall, they kind of work together as a unit, and they're going to carry a charge together of -1. You can think of it as NO3. Here's our nitrogen with 3 oxygens surrounding it, and overall, this whole thing is going to have that -1 charge. When you get into college and head into chemistry, you're going to have fun memorizing all of the different common polyatomic ions. Things like nitrate and sulfate and hydroxide, which is OH. That carries a -1, by the way. However, right now I will generally be giving you the information you need to know, but we're still going to learn the naming rules. It's very, very similar. except we're going to use the name of the whole polyatomic ion without changing the polyatomic ion's name, instead of naming each individual atom in that polyatomic ion. So let's see how this works down below. They've got an example where we're using calcium as the positive ion, and we're going to be using our nitrate up here as the negative ion. Calcium carries a positive 2 charge, and nitrate carries a negative 1. So I'm going to need 2 of those nitrates to cancel out the plus 2 calciums. So we've drawn in the formula here, calcium, and then we're going to put in parentheses NO3 for my nitrate, and I'm going to need 2 of those overall to cancel out. Now to name it, all I do is write the name of the positive element, calcium, and then I write the name of the polyatomic ion without changing its name now. So it becomes calcium nitrate. Let's try the same thing down here with silver. Silver has a plus 1 charge, so I'm going to write my Ag for silver, and I'm going to be combining it with nitrate, which has a minus 1, so I really only need 1 nitrate, NO3, to cancel out. Plus 1 cancels out minus 1, and I get silver and I don't need to change the polyatomic ion's name, so I get silver nitrate. A little bit hard to write in there. Let's move over here to sulfate. I'm doing calcium, combining it with sulfate in this box here. The calcium has that plus 2 charge, but you'll notice the sulfate carries a minus 1 charge, so they cancel each other out automatically. 2 plus on the calcium, 2 minus on the sulfate, I get CaSO4 for my big neutral binary compound. Let's go down one more box and we'll see how it works when silver combines with sulfate. Silver has a plus 1 charge, sulfate has a minus 2. So how many silvers am I going to need? I'm going to need 2 of those to cancel out. So I'm going to go ahead and take Ag2, and I'm going to combine that with 1 SO4. And to name it, I'm going to follow these simple rules. First, the name of the positive element, silver is positive, so silver. And then the name of the polyatomic ion without changing, so I get silver sulfate. Okay, pause the video here and then go ahead and work through the rest of this page and see if you can get it on your own. After you're finished with this side, come on back and we'll take a look at the next side.